Okay, in this video I'm going to do some examples of scrambling with B8ZS Scrambling, and I'll also do some HDB3 scrambling. And scrambling is intended to avoid long strings of zeros in the digital signal, because long strings of zeros in AMI encoding and in several other encoding techniques leads to a zero voltage, which prevents the receiver from synchronizing its clock with the signal. And so avoiding long strings of zeros is important for clock recovery at the receiver. And so, okay, I've got the first example is going to be a B8ZS Scrambling, and to take the digital data and make the plot. So let's see if I can do this. First of all, I'm going to copy the data, the signal, into, and then I've got 2, 4, 6, 8, 10, 12, 14 zeros. And 1101. Okay, so I've got 30 bits here, and I'm going to plot the B8ZS Scrambling. And the rule for B8ZS Scrambling is that I replace a block of 8 zeros, the first block you find of 8 zeros, let's go from left to right here, with a scrambling code. And that scrambling code includes 3 zeros, a bipolar violation, then a normal bipolar transition, a 0, a V, and a B again. And we're doing AMI encoding, and so AMI, a 0 gives a 0 voltage, and a 1 gives alternating plus or minus V naught as a voltage. And here's plus and minus V naught. And the B stands for a normal bipolar transition, which means I really do alternate between plus and minus V. Whereas a V means I've broken that rule, and I have a voltage which is the same as the previous non-zero voltage. And so I'm going to go ahead and assume that the most recent non-zero signal was positive, and therefore when I go to this first one, I'm going to go negative here. And then when I get to the second one, I go positive, and then a 0, and another one I go negative, and then I go 2 zeros, positive 1, a 0, a negative, and a positive. And now I've got my substitution code, and I go 3 zeros, a violation, and you can see the violation right here, 2 non-zero voltages in the same direction, a normal bipolar, a 0, another violation, and another bipolar. Here's my 2 violations. And now, how many zeros do I have here? 2, 4, 6 zeros. It's not enough to do a substitution. And now I've got a bipolar, a 1, another 1, a 0, and another 1. And that's how you encode this first set of bits with a B8ZS Scrambling code. The next one, 101, and then 2, 4, 6, 8, and then a 1, then 1, 2, 4, 6, 7, 4, 5, 6, 7, 8, a 1, and then 7 zeros, 3, 4, 5, 6, 7, then a 1, and then 2, 4, 6, 8 again, and then 2 ones. And again, the most recent non-zero signal level is positive, so our first one goes down to negative V naught, then up to 1, and now I've got 8 in a row, and so I go 0, 0, 0, V, B, 0, V, B. And so 3 zeros, here's a violation, a bipolar, a 0, another violation, and another bipolar. There's our violation. And now I have a 1. And now I have just 7 zeros. So I go ahead and I don't do a substitution. Now I do a 1. And now I've got 8 zeros again. 0, 0, 0, VB, 0, VB. 0, 0, 0. Here's a violation, a bipolar, a 0, a violation, and a bipolar. And then finally 2 more bipolars at the end, and I've got my 2 violations there. And so this is the first example of B8ZS scrambling.